the x value where it started, it's going to start at 1, and it's going to end at 5. Okay. So that was from 1 to 5 on the x-axis. That's when our graph is constant. So when they ask you increasing, decreasing, or constant, you are going to write the x values where that occurs. Okay. We're going to do one that's got infinities in it, where it's not a definite endpoint at the beginning and the end, just so you'll know how to write an increasing, decreasing, or constant if you have an infinity in there. Okay. Just so if you want all the words down, and you can have a picture if you need it. Increasing is going up, decreasing is going down, constant is going straight across. Make that point be the minimum there. I'll just curve mine a little weird. That should be it. 1. All right, so we have an ordered pair at -2, 2, and an ordered pair here at 1, -2 for this. Okay, how many different sections of the graph are there on this one? How many different sections? There are 3, right? We increase, then we decrease, and then we increase again. Okay, so it might help if you write somewhere on top or bottom that we are increasing, then we will decrease, and then we increase again. So for the first section, for this increasing one, these are going all the way to negative infinity. Where do we stop increasing in this first section? What's the last x value where we're increasing? At -2, right? Our last x value to increase is at -2. So our graph is increasing from all the way from the left until we get to -2. So if you're going to write that in interval notation, just think about our inequalities. This increasing section is from negative infinity until you get to -2. We stop increasing here. Okay. Between which two numbers are we decreasing? From -2 until we get to 1. So our decreasing interval is from -2 until we get to 1.
Okay, so how is that 1?
Right here, this x value is 1. This is where we stop going down and we switch to go back up. You're looking at the x values.
Oh.
Yeah. And then the next one, we start increasing when x equals 1. And we keep increasing forever, right? We're not going to turn back down anywhere. So to increase forever, we're going to say from 1 until we get to infinity. So if you're thinking about your number line, that's basically what we're doing is we're taking our number line and we're cutting it into sections. This section, our graph increased. This section, our graph decreased, and this section, our graph increased again. Okay. But when you write your answers, a lot of times they just want you to write that increasing would be from negative infinity to -2, and also from 1 to infinity. Decreasing is from -2 to 1. So you can make them a list. Like after you write them on your graph, you can just make a list on the side. This is my sections where it was going up. This is my section where it was going down. Okay. Any questions on our increasing, decreasing, constant? All right. Remember, it's the x's. Think about your x-axis kind of like a number line. You're splitting that up. And the last part, this is our extrema for this section. Then we have 2 examples from the next, and we'll be done. What's the root word in extrema? Extreme, the extreme values. So when you're thinking about a graph, the extreme values are your maximum values and your minimum values. So these are our maximums and minimums. Okay. So I'm going to draw 3 separate graphs, and I'll tell you the different types of extrema that we have in each of these graphs and where they're located. Do another cubic one. So the first one is a quadratic whose vertex is at 3, -2. Second is a cubic that goes through -3, 2, 0, and 2, -1. And it goes up, down, up. And the last one we'll look at is just a cubic that just does a little teeny tiny curve. So these are 3 different graphs with 3 different situations for their maximum and minimum values. The first one is the one that you've probably done before with your quadratics, and you're figuring out what the vertex is, and then that tells you if it's a max or min. Is your graph upward? Is it downward? But let's see. So go ahead and make a point on the lowest value of this quadratic on your page. So just go ahead and make a pretty big point on the very lowest value that you see. Okay, was your point right here? Yes. Since it's the lowest value, is this a maximum or a minimum? It's a minimum. Okay, so this is a minimum.
Are you talking about lowest, like, out of all of them? That's the lowest point?
Yeah, like the lowest y value, the smallest y value. Yeah. So this is a minimum. Okay. And the minimum value is -2. So the minimum is -2. And it occurs when x equals what? -3, right? So the minimum is -2, and it happens at x equals -3. You might see that written in ordered pair form, but you could also write it this way. The minimum is at -2. That happens at x equals -3. This type of minimum is called an absolute minimum. The minimum is the y right here. The lowest it goes is -2. And that happens when x is -3. Right there. This one is called absolute because it is the very lowest point on the graph. There is no other point any lower than that point. So it is the absolute minimum for this graph. Okay? Let's do a little scoot over to the next one. Is there an absolute lowest point on this graph? Now, what's going to happen with this arrow? This is going to go all the way down to -infinity. So there's not an absolute lowest point. Is there an absolute highest point or an absolute maximum? No. But are there some places that if you zoomed in really close on the graph, it would look like a max or a min?
Yes.
Yeah, there are two of those on this one. We don't call them absolute because it's not the very highest overall or the very lowest. We call them relative. So we've got a relative max and a relative min. I think about relatives or people that you're close to. So when you're close to this, it looks like it's the maximum, or when you're close to that, it looks like it's the minimum. So this is our relative max and our relative min. So our relative maximum would be 2, and that happens when x equals 3. I'm just going to write the ordered pair just because I'm going to run out of space. That's -3, 2. And we have a relative minimum at which ordered pair? 2, -1. Thank you, Jeremiah. I saw those hands. At 2, -1. Some graphs might have an absolute max, but then also have a relative minimum. That could happen. But the absolute, remember, is the very highest or very lowest point for the entire graph. Relative is just if you're zooming in. It's where your graph switches directions for those. All right. Look at the third one. Does it have an absolute max or min? No. Does it have a relative max or min? No. This has got no extrema. There's no point where we change from increasing to decreasing or vice versa. That's another way to think of your extrema. This is from decreasing, we switch to increasing. Increasing, decreasing, increasing, increasing. So there's no extrema there. Right. One last thing I forgot to mention, and I bet y'all remember this from the way back days, is if something's a function or not. We've been doing this forever. Before we go to average rate of change, y'all can tell me real quick, yes or no for these. Remember your vertical line test? Which one of these is not a function? Number 1, 2, or 3? 3, right? So this is a yes and a yes and a no. Remember your vertical line test, it touched it more than one spot? Okay. Just a reminder of that in case that shows up on anything that you do. All right, the 2-4 part is average rate of change. All it is a fancy way of saying slope. If you know your slope formula, it'll all be awesome and you'll be perfect in all of the things. Are you ready for a section that's super easy and finding the slope over and over and being perfect in all the things? I think so. There's no domain and range. The average rate of change is going to calculate between 2 points the average rate of change. How do the 2 points compare from where you started to where you ended? How did your y's change over how did your x's change? So a fancy way for us to say this is with our delta symbol. You might have seen these in science. Delta means change. So change in y over change in x. And when we say change, that just means the difference between them. So we can write this formula that, I don't know, you've probably seen before. Y2 minus Y1 over X2 minus X1. Does that ring some bells? Yep, that's just the slope formula for that, okay? And one other way that we can write the average rate of change, we don't really use it a whole bunch, but it does show you exactly what you're doing. But if you know about ordered pairs, you can use the slope formula. Is that sometimes they give you two values, A and B, and a function, and they want you to evaluate for it. So you could also see it written like this: f of B minus f of A over B minus A. This is just saying if your x values are A and B, to find your y values, you just plug them into the function. So it looks like a fancy way, but it's really just saying x values and y values. Remember, to find a y value, you just do f of x, and that gives you your y value. I know this is taking a long time. Stupid computer. So this is the way these problems are going to look. They're going to say, here's a function. We want to find the average rate of change between x equals 2 and x equals 5. So we have our x values. What else do we need to use to have to find the slope?
Y values.
The y values. So they give us the equation. So we just have to plug our x's into the equation to get our y values. Okay. So I just write, I'm going to do f of 2 first. And plug it in. And all math geniuses know that is 8. All right, 2 squared is 4, times 2 is 8. Now y'all plug in 5, and we'll see if we get the same thing.
So they two would move.
Huh?
Why is like F for two? They two would go nowhere.
To do
Never
it,
mind. I see this.
You're plugging the 2 in for x. Yes. All right, go ahead and do 2 times 5 squared. Jeremiah got it. Let's see, anybody else? Anybody else want to show me with your hands, or you can hold your paper up? Yeah, that's right, Kiara. Armani, that's good. Yes, Marlon. Yep, Dominic, that's good. Anybody else want to show me? Good, good. Y'all are all reversed on my screen, so everybody's just holding up a 0 and a 5. But it is 50, so I know what you mean though. So 50, 25 times 2 is 50. So what we've got now are two ordered pairs that we can use to find the slope. So this ordered pair is 2, 8. This ordered pair is 5, 50. And now just do your slope formula. 50 minus 8 over 5 minus 2. Fifty minus 8 is 42. 5 minus 2 is 3. And we get 14. So our average rate of change is 14. That means for every 1 x unit, it is going 14 units up. Right. Everybody okay finding a y value? Now you have an ordered pair and you can make the slope. Okay. All right, last one. So we're going to do 3x minus 1 between a and a plus h. So what's the first thing that we need to do or we need to find?
The y.
The y, right. So our first x value is a. So we're going to do f of a. And we plug a in here. We have 3a minus 1. So it's kind of weird, but that's are going to be our y value. So our ordered pair is a, 3a minus 1. Okay. Our next x value is a plus h. So we're plugging a plus h in for x. What do we need to do?
Distribute.
Yeah, distribute. So we have 3a plus 3h minus 1. There's nothing else we can do there. I picked one that didn't have a squared. If you have a squared, you're going to have to FOIL it out and everything. So this ordered pair is a plus h, and then 3a plus 3h plus 1. Minus 1, sorry. Okay. Now we have xy and xy. We're thinking about our slope. Remember, this is x1, y1, x2, y2. So let's just go ahead and plug it into our slope formula. Y'all ready to be done? Yeah, I feel you. So we got 3a plus 3h minus 1. That's our y2 minus 3a minus 1. I put it in parentheses because it had two terms. So that's y2 minus y1. y2 minus y1. I just rewrote those. Everybody okay with that part? Just like a slope, y2 minus y1. All right, now the bottom is going to be x2 minus x1. x2 was a plus h. x1 was a. Does this look familiar at all? It's just the difference quotient. So that was f of a and f of a plus h. And look, we have a minus a, so the only thing left on the bottom is just going to be h. So the difference quotient is just a fancy way of doing slope. Do you remember that most of the stuff cancels up on the top? Everything that's in that parenthesis is going to cancel. So you got a 3a and another 3a, and they're gone. And you got -1 minus -1, and that's gone. So what's the only thing left on the top?
3h.
3h, and on the bottom was h. So that's just going to equal 3. Because the h's go away. Okay. So for this, it's the same process. You just have some letters left when you're doing your slope. But same thing, y2 minus y1 over x2 minus x1 to find the slope between. Okay. I'm going to try and pull up that domain and range thing. If you were good on the domain and range stuff, you can go ahead and start working. Oh, I was going to show you real quick if I can. On your assignment, there are two parts. One part is CUDA, and it's just increasing, decreasing, max and mins, and rate of change stuff. But the other part, where does it say homework 2, 3, and 4? Here we go. So you've got a short answer part that you'll have to write down. But the first one's really easy. It's just increasing, decreasing. You're just writing the intervals on your page. That's not too bad. The second one is just finding like f of the number. I mean, it says g, but that means the same thing. You're just going to go to the x and figure out what the y value is. So that's like what we did at the beginning. Oh, just a second, Caitlin. I'll answer it in a second. On this one, when they give you a graph and ask you to find the average rate of change, just write down the ordered pairs that you have and do the slope. So anytime you have a graph like that, just write your ordered pairs down and do the slope. So you just have to have ordered pairs in order to do average rate of change, and you can find them from this picture. So just find your x and y values. All right. Same thing on the next one. They said between these two numbers. So go to those numbers, find your ordered pair that matches them, then just do the slope between that. So just write out your ordered pairs. And if you have a table, same thing. They said between 84 seconds and 200 seconds. Your ordered pair for the 84 seconds would be 84, 400. The other one would be 200, 800. So use those ordered pairs. So you might have to get y values from a graph. You might have to get y values from a table. The ones that we did, we just got them from a function. Okay, so once you look at it, just write x, y in ordered pairs and then do your slopes. I couldn't find any of those on the CUDA software, so I had to put them on here. I don't like it when you have two parts of the assignment, but I just couldn't find them. Okay, now I'll look for the other thing, if I can find it. I guess I can just pull it from Google Classroom.